So this time that we're taking the slices perpendicular to the y-axis. So that just is going to change the shape of the thickness. So that means I'll be doing dy integration. Okay, so let's look at this graph, x equal y squared. So it's the sideways parabola. And if I look at this graph, x equal 8 minus y squared, that's shifted up 8 and facing down. So there's 8 there. All right. So this is the bottom of the cake. Right here is the bottom of the cake. And when I take slices perpendicular to the y-axis, so that means slices are this way, and that means I must use dy integration. The shape of the slice are rectangles. So there's taking a slice, so there's a rectangle popping up out of the base. So let's go find the area of the rectangle. See, the area of the rectangle is base times height. And they tell me the height is 3 times the base. So 3 times the base for the height, and then base. So my area equation is 3 times base squared. So I need to find this distance here because that is the base. So I can see that the base is going to be the top, subtract the bottom. So the top function is the 8 minus y squared, and the bottom is the y squared. So the base is 8 minus 2y squared. So 8 minus 2y squared for the base, and I'm squaring the base, correct? All right, so now I'm going to take the volume, and that's going to be the integral of this area. And then I need to decide where I'm going to be making the these rectangles from and to. Remember, it has to be on the y-axis. So it has to be on the y-axis here to here. So I know I find those values by setting them equal to each other. So I have y squared is equal to 8 minus y squared. So 2y squared is 8. Y squared is 4. So I get y equaling plus or minus 2. So minus 2 to plus 2. All right, so let's take a look at this one. So here I have x equal y to the 2/3. So this is the sideways graph like this. And then I have x equals 16. So that looks like this. All right, so now I'm doing perpendicular to the y-axis. So that means slices go this way. And I have semicircles popping out. So the base of the solid, base of my cake, that's the bottom of the cake. Cakes are always flat. And I'm making a slice. So coming up out of the bottom of the cake are semicircles. So the area of a semicircle is 1/2 pi radius squared. So this one's a little extra challenging because I need to find the radius. The radius is not the diameter. So what I have here, this distance here to here, is the diameter of the semicircle. So let's first find the diameter, and then we know that the radius is 1/2 of the diameter. So a little extra work in here. Okay, so what is the diameter? What is this distance here? So that distance is going to be 16 minus y to the 2/3. So if the radius is half of the diameter, it's going to be 1/2 of 16 minus y to the 2/3. So the area will be 1/2 pi. And then I'm going to put the radius in, which is 1/2, 16 minus y to the 2/3. And then I'm going to be squaring all of that. So this, all of this goes into the integral to find the volume. So 1/2 pi, 1/2, 16 minus y to the 2/3, all squared, dy. All right, last thing to do is find the limits of integration. So I need to find out where 16 equals y to the 2/3. So that's like taking 16 to the 3/2 power. So that's taking the square root of 16, which is 4, and cube it, and so that's 64. And it's going to be plus or minus, because when I take the square root, I get a plus or a minus. So negative 64 to 64.